Hello everyone, today we will be solving permutation of a given string problem. So what is the problem? Let us understand that we are given a string ABC. Let's suppose the string is ABC and we have to find all the valid permutation of this string. So the length of the string is 3, so number of permutation will be 3 factorial, right? Okay, so let us write the permutation first. ABC is one of the permutation, ACB, BAC, BCA, CAB and CBA. These are the all permutation of the string ABC. Okay, so how can we do that? Given a string, we have to find all the permutation of the string. So if we use the recursion and we have A, and recursion give me all the permutation of BC, that is BC and CB, and we will attach A to it. As we can see that for the given string ABC, all the permutation, we have two string which start with A, we have two string which start with B and two string which is starting by C. So you can see that if recursion give me the permutation of BC, that is BC and CB, and if we attach A in front of it, we can get all the permutation starting with A, that is ABC and ACB. Okay, so how can we do that in programming? We can have starting symbol A twice, B twice and C twice, right? So if we traverse the string, 0 index will be starting symbol twice, the ith index, then B will be twice and C will be twice. Okay, so how can we pass the string to recursion to give us the permutation? In Java we can use substring, that is for the string dot substring from 0 to I plus string dot substring I plus 1. Okay, that is nothing but if B is I, then this will be A and this will be C. So we will have all the permutation from AC, and then we will attach to B to it. Okay, so let's do the coding part. Okay, we will need to return a list of string. So list of string result, and we will function, let's say the function solve, which will solve the recursion. Okay, we will pass the string S, we will pass a empty string which will contain every possible permutation of the string. Okay, so our empty string and the result, and we will return result. Okay, let's do the solve function. Let's complete the solve function. So it will return void, the function will return void. Okay, so string s, the blank string, that will be every permutation and a list. Okay, so we will need to run through every element, and for each substring we will need recursion to give us the permutation of the substring. So our loop will be start from int I equal to 0, from 0 to the length of the string, and we will call solve on this string. The I is a, and we will call solve and get permutation of b and bc. Okay, so the string will be a dot substring 0 to I. In first case it is 0 comma 0, so it will be a blank string, plus string substring I plus 1. So it is similar to write I plus 1 comma the size, or just only I plus 1. Okay, so I plus 1, this will be our string. Okay, our permutation string will be permutation string plus the ith character of the string. Okay, so s dot character at I, and we will pass the result. Okay, okay, and what will be our task? That list dot add result. But when we will add the result, oh sorry, list, our task will be result dot add the permutation string. And when we will add the permutation string to this, when s is 0, s length is 0, so if s length is 0, what is the base condition? The string length is 0, and our list doesn't have the permutation string. Okay, then we will add permutation string to the result list, and we will loop through. Okay, and we will return, right? Okay, let's compile and run. Okay, so just okay, sorry. So you can see that we have got all the permutation of the string. One more thing that mention here is we need to send the result lexicographically sorted order. So we will just sort the result. Okay, now so submit the code. To row is done. Okay, So what is the time complexity of the code? What is the time complexity of the code? Time complexity, it is big of n factorial. Okay, because we have n factorial number of permutation of a string. Okay, where n is the length of the string. Okay, n factorial number of permutation, so the recursion will take big of n factorial. So time complexity is big of n factorial. And what will be the space complexity of this code? Okay, so tell that in the comment section.